Good morning, students. This is Architra. Today, I would like to discuss about esterification. The esterification. Carboxylic acids are carboxylic acids are react with alcohols. Carboxylic acids are react with alcohols in presence of concentrated H2SO4 gives esters. Plus H2. This is called formation of ester. This is called formation of ester. Aim. Formation of ester. Formation of ester. Materials required. Materials required. Acetic acid. Acetic acid. Ethyl alcohol. Ethyl alcohol. Test tube. Beaker. Tripod stand, water, Bunsen burner, chemical equation, CH3COOH plus C2H5OH gives rise to unconcentrated H2SO4 gives CH3COOC2H5 plus H2O. Procedure. Take a test tube. Take a test tube. In that take 1 ml of glacial acetic acid. And 1 ml of ethyl alcohol. To this add 2 or 3 drops of concentrated H2SO4 and then heat on water bath for few minutes. Say diagram must be important. This is a tripod stand. place a tripod stand, keep a baker. Few minutes. Observation. When we add the mixture in test tube added to water, when we add the mixture in test tube added to water, that gives sweet ordered ester. Sweet ordered ester. Once again, see, esterification means carboxylic acids are react with alcohols in presence of concentrated sulfuric acid gives esters. This is the skeletal equation. Aim: formation of ester. Materials required: acetic acid, ethyl alcohol, test tube, baker, tripod stand, water, Bunsen burner, like this all. Chemical equation: ethyl alcohol, acetic acid plus ethyl alcohol in presence of sulfuric acid gives ester plus water. Procedure: take a test tube. In that one, take 1 ml of acetic acid and 1 ml of ethyl alcohol. To this, add 2 or 3 drops of concentrated sulfuric acid and then heat on water bath for few minutes. When we add the mixture in this test tube, add it to water, that gives a sweet ordered ester. Precautions. Be careful while heating the solution. While heating the solution, be careful with concentrated sulfuric acid. Be careful with concentrated sulfuric acid. Next one is saponification. Alkaline hydrolysis of triesters of fatty acids. Triesters of fatty acids gives soaps are called saponification. First, alkaline hydrolysis means dissolving in base, dissolving in aqueous base. Triesters of fatty acids. Here fatty acid means, in general we use stearic acid or oleic acid. What we should use, Nana? Stearic acid or oleic acid. Stearic acid means C17H35COOH. This is called stearic acid. stearic acid. 3 moles of stearic acid is react with glycerol. CH2 bond CH bond CH2 OH OH OH. This is called glycerol. Then that should be give triester of fatty acid. CH2 bond CH bond CH2 bond O bond C double bond O C17H35 bond O bond C double bond O bond C17H35 bond O bond C double bond O bond C17H35. This is called a triester of fatty acid. Stearic acid first dissolved in glycerol, that gives triester. R bond O COO bond R dash is called ester. This is a triester of fatty acid. This is triester of fatty acid is dissolved in base. Alkaline hydrolysis means that dissolved in aqueous base. That dissolved in aqueous base. However, that should be means C17H35 C double bond O bond CH2 C17 H35 C double bond O bond CH bond CH2 C17 H35 C double bond O bond O. This is called a triester of fatty acid is dissolved in aqueous NaOH. Aqueous NaOH that gives soap C17 H35 COONA plus again glycerol will form. However, that should be means here 3 OHs are attached to this one. Here one A, Na, here one Na, and here one Na forms 3 moles of sodium stearate, and again glycerol will form CH2 bond CH bond CH2 OH. This is called sodium stearate. Glycerol. Saponification means alkaline hydrolysis of triesters of fatty acids gives soaps. First, what is meant by triester of fatty acid? Here, fatty acid means stearic acid we taken. 3 moles of stearic acid is dissolved in glycerol, that gives triester of fatty acid is given. This triester of fatty acid is dissolved in alkali means aqueous base. Alkali means aqueous base, that gives sodium stearate. This is called soap. Sodium stearate. This is called soap. This is called saponification. Most important. This is a regular 8 marks question. Define saponification and explain the working action of soap or cleaning action of soap. Now we would like to discuss about working action or cleaning action of soap. See, working action of soap. Working action of soap. When small amount of soap is dissolved in water, when small amount of soap is dissolved in water, that forms low concentrated colloidal solution. Low concentrated low concentrated colloidal solution. A colloidal solution contains two types of phases. One is a dispersal phase and another one is a dispersal medium. Here, soap is dispersal phase and water is dispersal medium. Soap is solute particles and water is solid molecules. Colloidal solution means in a solution, solute particle size is in a solution, solute particle size is solute particle size is in between 1 nanometer to 100 nanometers. That solution is called colloidal solution. Here, that colloidal molecules are aggregate together. This is called critical concentrated micelle. I mean aggregation of these colloidal molecules. Critical concentrated. This is called. This low concentration is called. This low concentration is called critical micelle concentration. Critical micelle concentration. What is meant by micelle? The aggregation of all colloidal molecules together at a particular point. See here, how well it is means soap molecule means C17, S35, COONA plus COO minus. This is polar end, this is non-polar end. Like this is there, COO minus Na plus. This polar end is called hydrophilic. This is called hydrophobic. This all hydrophobic ends are collected together at a particular point. This is called aggregation of colloidal molecules. See, like this is there. The aggregation of all colloidal molecules. Aggregation of all colloidal molecules. All are COONA, all everything. This is called aggregation of that all colloidal molecules. Aggregation of all colloidal molecules at a particular point is known as micelle. This concentration is called critical micelle concentration. Its concentration is called critical micelle concentration. Now we would like to discuss about cleaning action of soap. Cleaning action of soap. Cleaning action of soap. While the soap is dissolving in water, while soap dissolving in water, while soap is dissolving in water. The hydrophobic end and hydrophilic end. Hydrophilic. This is hydrophobic. This hydrophilic end is mixed with water. The reason is water is polar in nature. 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 So the hydrophilic end is the hydrophilic end mixed with water. Mixed with water, and hydrophobic end mixed with oil and grease. They form immediately micelles and remove the stains easily. The reason is oil and grease are non-polar in nature, so the non-polar substances are mixed with non-polar solvents. So here hydrophobic end is non-polar, oil and grease are non-polar, so both one are mixed with each other. Hydrophilic and polar in nature, water also polar in nature, so they would like to mix it with water only. See that and grease are collected together at the bottom of the bowl. What we use at the utensil, and that one black, that is spots are found, that is only called the grease and oil aggregated together, that is only is called micelle. This is working action of soap. From this one the entire lesson is completed. I posted nearly 12 videos. If you would like to watch the videos continuously without fail, you would like to answer to any question which should come from carbonates compounds. I clearly mentioned every word on the basis of every skill based question. I hope that you would like to understand and you would like to answer to every question. So you have to watch continuously these 12 videos. This lesson is completed. Thank you.